All right, so we're starting our last unit, which is about absolute value. Whoa. Absolute value as well as reciprocal functions. We're going to focus on absolute value today, and we're just going to look at like basically how to graph these things. Before we do that, we need to figure out what absolute value actually is. It looks like this. You've always wondered what that button on your keyboard does that looks like that vertical line. That's what it is. That's absolute value. The idea is that any negative number that is inside of this setup, kind of looks like brackets basically, turns it into a positive. So if I had something like this, it doesn't matter what value I put in for x. If x was like 100, that would give me negative 95 as the answer. But because it's absolute value, it actually turns into 95. So essentially, you cannot ever get a negative number as a result of absolute value. Turns it positive. So when we're graphing, the way that that looks like is that we never actually get a part of the line that goes below the x-axis. It's always, always, always going to be on this top part, like this V shape or this weird like W shape, whatever. So we need to know how to graph these actual equations. We're going to be able to do linear as well as quadratic. Let's start with the linear ones. Okay, it's going to look something like this. Y is equal to absolute value of 2x minus 4. The way that you're going to graph it, the first thing you do is imagine it wasn't absolute value. Just write it without the absolute value markers. So I'm going to write the graph y equals 2x minus 4. The way you would do that, let's do it with green. I'm going to start at the y-intercept, right? Negative 4 down here. And then my slope is 2, so I'm going to go up by 2 and I put all my points. Cool. The only problem is, again, this is absolute value. So what we're going to do is wherever the line crosses that x-axis and goes below, we're not going to include it. We're going to like ignore those dots. So this part of the graph, this part right here, that line is good. That's normal. That's part of our final graph. What we're going to do next is all the values, all the points that are below the x-axis like this are going to move up and they're going to be reflected. So in this case, let's look. This point was at negative 2. It's going to move up and be at positive 2 for y. This point's at negative 4. It's going to move up and be at positive 4. If we continue the pattern, right, see some points over here, they would move as well. So what ends up happening, and when we connect those lines, we end up getting this like V shape you can see. Let's erase it for a sec. You get that V shape where everything kind of bounces off of the x-axis. That's the process of how we do it. The other thing that's important to know is this bounced line that we can see here is actually, if we think about it, y equals the negative value of 2x minus 4. So our normal equation, what we started with was here. And first we graphed what it normally was, like without the absolute value. That gave us this part. But when we want to see the second part, the reflected part, you just put a negative in front of the x. And when we expand that out, we get this. Y equals negative 2x plus 4, which when you think about it, you start at the 4 on the axis, that's where we were, and the slope is negative 2, and this goes down by 2. It makes sense, that's what it is. So it's kind of like two equations in one. One is the normal part, and one is the reflected part after the bounce. So when we do quadratic equations, it's going to work the exact same way. I'm going to start by looking at my graph. Okay, I'm going to graph it as if there was no absolute value to start. So it's in vertex form, so I'm going to graph my vertex, which is at negative 4 and 1. Sorry, 1 for the x and negative 4 right there. Okay, and then there's a value of 1, so I'm going to go over 1, up 1, over 1, up 1, and I put the rest of my points like I normally would. Cool. Okay, I'm going to draw my parabola, but instead of going below the 0, because like we talked about, you can't go below the 0, I'm going to stop. Then those 3 points that were at the bottom, I'm going to translate up or reflect them on the x-axis. So again, this green point down here at the bottom was at negative 4. It moves to positive 4. This was at negative 3 and negative 3, so it moved to positive 3, positive 3. And you're going to notice it makes this weird like bounce thing. So it looks kind of like that with the weird divot in the middle. A lot of them graphs are going to look like this. That's just how they're shaped. And that's the idea. Again, our normal graph, that the red line right there, that is our y equals x plus 1 squared minus 4. The red line, oh sorry, that is the red line. The green line, that weird bounced middle part, is actually the negative value of the entire equation. So it would be like this, negative x plus 1 squared plus 4. Okay? So that second part, that bounced part, is kind of like a parabola of its own that would extend. But again, we're only looking at that top part. Let's do 2 more examples because it is kind of weird. This one. Okay. Y equals 2x minus 3, absolute value. Okay. So I'm going to graph it as normal. Start at negative 3, go up by 2 every time. Oh, sorry. Went up by 3 there. Looked kind of weird. There we go. Okay. So I got my line. I'm going to draw the line, except I'm going to stop there. I'm not going to connect those points. I'm going to translate them and reflect them about the x-axis. So this is going to become 1, and this is going to become 3. There we go. And that's the reflection. So if we had to graph it, that's what we got. It is a little hard to see what that exact point is, and we're going to learn next class how to calculate what that value is, but that's it, okay? If we have to graph it, that's all. Now we'll look at this one, the second one. Let's set it up. So I got my 2 intercepts, so -1 and -3. Cool. I know the graph's going to go up like this. I could be more accurate if I wanted, but I don't care. The vertex would be here, but we're going to have to reflect it about the x-axis, so it's going to go there. And again, we get that weird bounce, and that's the whole graph. So that's how we set those up.